Representing and Displaying Data Part 3. We are going to take a look at stem and leaf plots and scatter plots. Stem and leaf plots. You should use a stem and leaf plot when you want a quick way to display each data point. So again, this is going to take a look at each specific data point as opposed to like a histogram, which would not look at each data point. This is a special table where each data value is split into a leaf, which is the last digit, and a stem, which is any other digits, and we'll talk about that in a second. Don't forget a title, and you will need a key for this all the time. So let's look at the first one. These are all two-digit numbers, which makes it kind of easy. Locate your lowest number and your highest number. The lowest number is 31, and the highest number is 67. My lowest stem is going to be a 3, and my highest stem is going to be a 6. And then I just fill in the others. My leaves then are going to be all the other digits. Now, often we can use a rough draft for this, so I might over here go 3, 4, 5, 6, and then work my way from left to right. 5, 7, you see what I'm doing? I'm just taking the second digit off there. 9, 3, 31, 60, and I work my way across the data set. Once I have my rough set, then I can put them in order on my final copy. So this would be a 1 and a 5 and a 9. We're also going to list the digits underneath each other so that it's going to be a descriptive graph as well. So as you can see, pretty much I kind of lined them up here. And if you were to turn this sideways, it would be like a histogram, because the numbers in the 30s, I have 3, the numbers in the 40s, I have 5, and it would give me some kind of an idea. I do need a key, so at the bottom I'm going to write key, and 3/1 means 31. That's the basic idea, and I would have a title here, survey, whatever the survey is. Okay? So try the next one on your own, keeping in mind that when there's a 3-digit number, your stem is going to be a 10 and your leaf is going to be a 7. Go ahead and try this one on your own and come back and check with me. So here's the second graph, the stem and leaf plot, and you should have a key. You should have a title. I realize there's not really anything there, so you could have survey, random numbers, whatever. Now in the bottom, we want to put all of those Harry Potter actors into a stem and leaf plot. So they have given you a rough version, so you can go ahead and complete this on your own and then come back and check the final plot. This is what the Harry Potter stem and leaf plot should look like. Make sure you have a title and a key. Now we're going to move on to scatter plots. You'll need to page through in your packet a little. Looks like this. Scatter plots are graphs of plotted points that show relationship between two different sets of data. The data is plotted on the graph as Cartesian coordinates. So in other words, it's like we're graphing and plotting points. Scatter plots are used when you want to display a large number of data points or you want to display a cause and effect relationship. If you look at the graph to the right here, it's comparing height to weight. And there may be a cause and effect or there may not. And that's what we're trying to look at with a scatter plot. Now, correlation is how they relate to one another. This is their relationship. So when we talk about correlation here, the correlation is positive when the values increase together, like our graph to the right. Correlation is negative when one value decreases as the other increases, and we'll look at that down below. If you look at the graph shown, perfect positive correlation, the first graph, is when the line can exactly be fit to those points. A high positive correlation is when a line can almost be fit to the points. Low positive correlation in graph 3 looks like they're moving in the same direction, but you'd have a hard time putting a line there. No correlation is graph 4. They're just scattered all around. And then we can go in the same direction with a negative correlation. So in graph 5, they're definitely negatively correlated. It's sloping in a negative position, but it would be a hard graph to fit a line to. 6, you could pretty easily fit a line in there, but it's not exact. And then the perfect one would be where you could exactly put a line through them. So go ahead and pause here and look at the next 4 graphs and tell me what you think. In the first graph, I see a high negative correlation. In the second graph, I see no correlation at all. They're scattered around and nothing really makes sense. In the third one, and I think in the fourth one, they're both highly positive. The fourth one seems to be a little bit more in a line than the third, but that's debatable. Now this comic down here is kind of interesting. Remember that correlation is how they're related. And it says, I used to think that correlation implied causation. Then I took a statistics class and now I don't know. Sounds like the class helped, she said. Well, maybe. Statistics classes are very confusing, I will say that. And quite honestly, correlation may or may not be related to causation. We don't know just because they have a correlation that one thing caused the other. So you really need to think about that as we're working through scatter plots. We're going to create a scatter plot next, and what we're looking at here is a relationship between the number of cups of coffee sold versus the temperature it is. This is going to be a little bit tedious. You have to do the usual things, label, and then you have to plot those points. So it's like this is the x coordinate and this is the y coordinate. And so if you look at this graph, we're going to give it a title. My title is going to be coffee sales compared to temperature. And then we have to label both our sides. So we're going to put the cups of coffee sold here. I just went up by 5s because it seemed to work out nicely that way, even though the highest point is going to go a little bit above my graph. And then I put temperature on the x-axis, and I just went up by 2s there. I don't need to worry about starting my x-axis at 0, so that's fine. Then we're going to plot each of those points. So you should be able to do that. Now I can tell you, you have a couple I think there that lay on top of one another. You're going to have to estimate some of them. For instance, you have a 68 and an 11. Well, the 68's right here, but the 11, well, this one's 15, this is 10, so you're just going to put it right there, kind of above 10. Go ahead, plot your points, and come back and check your graph with mine. So here we can see that the points are pretty much plotted. Some of mine look a little blurry because I have 2 points there. And I could fit a line there. So let's look at the questions. Describe what you notice from the diagram. Is there any correlation? Sure. There's a negative correlation and a pretty high negative correlation. It asks you to draw a line of best fit. We will be doing this a lot next year. What you want to do is you want to try to go kind of in the middle. Asks you to hit the mean points. I'm not going to worry about that right now. What I'd like you to do is just kind of look at this to see if I put a line here, where is it going to fit best? Well, if I go like this, it hits a lot of the points, but it really isn't in the middle. So I kind of want to move it so that it would be sort of in the middle of all of my points. And then it asks on another day it was 61 degrees. So if it's 61 degrees, we want to then estimate how many cups of coffee would be sold. So we can go up to our line and we could say, oh, maybe about 61 or 62 would be based upon my line of best fit. That's basically a scatter plot. So we'll take a closer look at these tomorrow. Have a great night.